Before you view this lecture, make sure that you know the domain and ranges of all of our inverse functions that we've talked about. Know the domain of arc sine, arc cosine, arc tangent. Okay? Let's take a look at a typical example. Let's evaluate the sine of arctangent 3/2. All right. Here's what we want to do. Remember, the arctangent is an angle. So what I'm going to do is I'm going to let theta, we usually call angles thetas or alphas or betas or whatever you want to call it. I'm going to let theta equal the arctangent of 3/2. Okay? So what I really want to do is figure out what is the sine of theta. Okay? Let's go ahead and draw a picture over here. Remember, the range of the arctangent is between minus pi-1/2 and pi-1/2. So this angle must be somewhere in between negative pi-1/2 and pi-1/2. So let's see if we can find it. Arctangent of 3/2 is the angle between minus pi-1/2 and pi-1/2, whose tangent is 3/2. Whose opposite over adjacent is 3/2. Now what we want to do is we want to find this missing side of this right triangle. Well, notice I've got an a and a b here, so I can go a squared plus b squared equals c squared. Just use the Pythagorean theorem. 4 plus 9 is equal to c squared. So c is equal to square root 13. Okay, so what we've done is I just let theta equal this angle, okay, and I found where that angle is. It's right here. Now then, what do we want to do? Well, we want to figure out what the sine of that angle is. Well, that's no problem. The sine of theta, remember, is the opposite over hypotenuse. So the sine of that theta is opposite over hypotenuse. And that's good enough. We might want to rationalize the denominator if we wish. Okay? All right, let's try a couple more. You should get the hang of it. All right, let's try to evaluate the tangent of the inverse cosine of negative 5/13. So I'm going to start it the same way. I'm going to call this inside an angle. How about let alpha, we'll just use alpha for our angle, equal arc cosine of negative 5/13. Okay? Well, that angle must be in between 0 and pi because that's the range of the arc cosine. So where alpha is between 0 and pi. All right, so let's draw a sketch of this angle. I'm looking for the angle between 0 and pi, whose adjacent over hypotenuse is negative 5/13. Means we have to be over here somewhere. So there's my angle alpha. And all I have to figure out is what's the tangent of alpha. Okay? Well, tangent is opposite over adjacent, so I have to figure out what this opposite side is. Again, I have a right triangle. By the Pythagorean theorem, I can find that b is equal to 12, and then we can go through that. You can do that on your own. Okay? So where are we? Well, we have to figure out what the tangent of that angle is. Well, the tangent is going to be opposite over adjacent, or negative 12/5. Okay? Try one more. Here's the problem. You might want to put the lecture on pause right now and see if you can figure out what the secant of arcsine of -4/9 is. Okay, so put it on pause, try to figure it out, and then follow along with me. All right, so let's see if you're right. I'm going to let, how about if I use beta? Doesn't matter what variable we use, but I'll let beta equal arcsine of -4/9. Okay, so beta must be an angle in between minus pi halves and pi halves. So let's go ahead and make a sketch. Beta is some angle between minus pi halves and pi halves. Okay. Notice it's a -4/9, so it's got to be down here in quadrant 4. Okay, so there's my beta. And I must have an opposite side of -4 and a hypotenuse of 9. All right. So remember what secant is. Secant is the reciprocal of cosine. So I need to find out what the, let's see, secant is going to be hypotenuse over adjacent, so I need this adjacent side. Again, let's just go ahead and use the Pythagorean theorem. 4 squared plus b squared is 9 squared. 16 plus b squared is 81. 81 minus 16 is 65, so b must equal square root 65. And there's my angle beta. Okay? So we now know all the sides of my triangle. So secant of beta must be adjacent, which is square root 65. No, excuse me, hypotenuse over adjacent is secant. So we have 9 over square root 65. And certainly we could rationalize that if we want. So the secant of arcsine of -4/9 is 9 square root of 65 all over 65. Okay, this is tricky stuff. Remember, what you need to know, you have to figure out what the ranges of these arcsines, cosines, and tangents are. Therefore, that will allow you to draw a picture. And then all we have to do is find the missing sides of the triangle, and then it's pretty much easy from there. Okay? So please stop by the Polio Math Center. Stop by your instructor's office hours, okay, if you need some extra help doing your homework.